In part 1 of our lesson on trigonometric functions of acute angles, we're going to learn about right triangle trigonometry. Now, if we take a look at this right triangle here, we see we have angle A, angle B, and angle C. Angle C is the right angle. And if you remember from your geometry class, the parts of a right triangle, it has two legs, and the legs are the sides that form the right angle. Then opposite of the right angle, it has a hypotenuse. Now, if we use our trig definitions on angle A, because we have angle A in standard position, we can use the trig definitions. Then the sine of angle A is going to be the y value divided by r. Now, if we reference these to the parts of the triangle, we see that y is the leg that is opposite of angle A. So this is the opposite leg. And r is the hypotenuse of the right triangle. Cosine of angle A, by using our trig definitions, we know is x divided by r. Now, relative to angle A, x would be the adjacent leg. Once again, r is still the hypotenuse. And tangent of angle A, we know by definition, is equal to y over x, and y was the opposite leg, and x is the adjacent leg. So in right triangle trigonometry, there's an acronym that we can use, and we say anytime you have a right triangle, like we do in this picture over here, then you can use SohCahToa. And that acronym stands for, the S is for sine, the O is for opposite leg, and the H is for hypotenuse. So when you read this acronym, you say sine is opposite over hypotenuse. You can see this part, the CAH, is for cosine, is adjacent leg over hypotenuse. And the TOA stands for tangent, is opposite over adjacent. Now, using the reciprocal identities, we know then that secant is going to be hypotenuse over adjacent. Cosecant will be hypotenuse over opposite. And cotangent will be adjacent over opposite. In this next example, we're going to use SohCahToa to find each trig value using the figure to the right. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. For sine of angle A, we know we're using opposite over hypotenuse, so that's going to be 15 over 17. Cosine of angle A uses the adjacent leg over the hypotenuse, so that's 8 over 17. And tangent of angle A uses opposite leg over adjacent leg, so that's 15 over 8. Cosecant A, we know, is the reciprocal of sine of A. We know it's hypotenuse over opposite, so we get 17 over 15. Secant A will be the reciprocal of cosine A, so it is hypotenuse over adjacent, 17 over 8. And cotangent of A is the reciprocal of tangent of A, so we know that it will be adjacent leg over opposite leg, 8 over 15. Now, one of the powerful uses of SohCahToa is the angle doesn't have to be in standard position. So you notice that even though A was over here, not an angle on the coordinate plane in standard position, we were able to find all of its trig function values. Now let's find the trig values for angle B. Sine of B is going to be its opposite leg divided by the hypotenuse, so that's 8 over 17. Cosine of B will be its adjacent leg divided by the hypotenuse, 15 over 17. Tangent of B will be its opposite leg divided by its adjacent leg, 8 over 15. Cosecant of B is hypotenuse over opposite, so 17 over 8. Secant of B will be hypotenuse over adjacent, so 17 over 15. And cotangent of B will be adjacent over opposite, 15 over 8. When using SohCahToa, some students confuse the hypotenuse with the adjacent leg. While the hypotenuse is a side of the angle and does help form the angle, the hypotenuse can never be an adjacent leg because it's not a leg at all. Remember the parts of a right triangle. The legs are the two sides that form the right angle. The hypotenuse is always opposite of the right angle. So the hypotenuse can never be an adjacent leg because it's not a leg at all.